Okay, blah, 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 methanol. What's a catalyst? Right, okay, you should know that these guys here are biological catalysts. Of course they are. Enzyme, job done. Right, so that was relatively straightforward. Next one. There's our methanol being produced in industry, okay, by reacting with hydrogen with carbon monoxide. And then we want one of these moles questions again. How many moles of carbon monoxide react completely with 4 times 10 to the 3 moles of hydrogen? Well, it's a 2-to-1 ratio. So all you got to do is that number divided by 2, because 2 of those divide by 2 to get the 2-to-1 ratio. Therefore, of course, the answer is this one here. Right. So this thing's carried out at 250 and 100 atmospheres. Forward reactions exo. Explain what happens to the yield if it is higher than 250. Okay, so what do we got? Forward is exo, endo, Right, so if you go hot, what happens? Well, it tries to do the opposite, so it goes cold. So therefore the yield is going to decrease. Oops, you can't see again. I'm written really bad at this. Where's it gone? Yield decreases. Okay, so of course we're in a state and explain. Why? Well, because equilibrium, that's his equilibrium, moves to the left. Because, or why does it move to the left? Well, it moves in the endothermic direction. In the endothermic direction. You will notice that this answer is not identical to what I was writing before, but it's exactly the same thing. So yield decreases. Yeah. Why? Well, because the reverse reaction is endothermic and the equilibrium moves to the left. So these are all the same things, really. Right. Pressure of 100 atmospheres is used instead of atmospheric, i.e. a high pressure. The high pressure gives a greater yield and an increased rate. Ooh, explain why. So we're doing all sorts here. So, first of all, let's talk about yield. If you increase the pressure, number of particles, so there are 2 on this side, there is 1 on this side, so the yield increases because less molecules on the right, so equilibrium moves to the right. Okay, then we want to talk about the rates. What's that about? Rate increases as there are more particles in a given volume, or if you like, per centimetre cubed. Please make sure you're writing this bit, otherwise I won't give it to you. So therefore there are more successful collisions. Right, okay, so that's that one. It's pretty standard stuff, really. Okay, where's me next bit? 15, 16, 16, there it is. Oh, right, that was me 4 points. Okay, done. So, catalyst, explain how the catalyst, oh, really, same one again. Right, so we're explaining it provides the alternative pathway, alternative, it does say that honestly, pathway, which has a lower activation energy. I'm getting proper lazy now. That's activation energy. All right. Suggest why the catalyst is used. Do not give it in terms of rate. So obviously one of the answers would be because it speeds up the rate of reaction, but they don't want that. So therefore they need something else. Well, it provides a lower activation energy. So therefore you're going to need less energy for the whole process, which of course will make it cheaper. If you put cheaper, that's fine. Suggest the effect of using the catalyst on the equilibrium yield. Right, that's the word. No effect. Catalysts do not affect the yield in any way. What they do is they increase the rate. Okay, so there is no effect whatsoever.